Alright, section 4.3 is called the Fundamental Theorem of Calculus, and it has two parts. Part 1 goes over what it means to be able to take the integral, and part 2 will go over how to actually evaluate it. Alright, so basically what the first part of the Fundamental Theorem of Calculus says is that if your function is continuous, that you can integrate it over the values that it's continuous on, and you can differentiate it on the values that it is continuous on. Okay, the second part of the Fundamental Theorem of Calculus tells you how to integrate a function. Okay, so the integral of your small f function from your lower limit to your upper limit tells you then that you need to integrate it to find your big F function, which is your integral function, and then take big F of your upper limit minus big F of your lower limit. Okay, which is what we did last week anyways. So if I look at example 2, I'm told that g of x is equal to the integral from 0 to x of the square root of 1 plus t squared dt. Okay, so we're differentiating along t. And it wants me to find g prime of x, so the derivative of g of x. Okay, so if I want to find the derivative of x, I'm going to differentiate along x for the integral 0 to x of the square root of 1 plus t squared dt. Okay, so basically I'm differentiating the right side of my function. In doing that, the derivative and an integral will always cancel because they're opposite functions. And so I'm left with then the square root of 1 plus t squared dt, and my values are x and 0. So anything to 0 just cancels, and so basically I just replace my t with an x. So my new function is 1 plus x squared. The shortcut to that is just taking this function f of x and replacing whatever letter your variable is with x, and you're done. So any questions on that? Makes sense? Kind of? Do you want to do another one? Kind of like that? Okay. Alright, so I'm given g of x is the integral from 0 to x of x squared divided, we'll do a different letter. Let's do m squared divided by m plus 1, differentiating along m. And I want to find g prime of x. Well, to find g prime of x, that's my derivative. So I'm going to differentiate my function for x. That's what d over dx means. And my function in this case is the integral from 0 to x of m squared divided by m plus 1 dm. Okay, so then my derivative and my integral cancel. So I'm left with m squared divided by m plus 1 dm evaluated from x to 0, or from 0 to x. Okay, we can ignore the 0 always. And so then this tells me that I'm going to evaluate for x, and I'm going to plug in the x everywhere that I see an m. So if I do that, I get x squared divided by m plus 1. You can ignore the dm. So g prime of x is equal to x squared divided by x plus 1. So make it a little better? A little clearer? Okay. All right, the second part of what we're going to do today uses part 2 of the fundamental theorem of calculus. So we're going to actually evaluate some integrals, which we also did last week. So if I'm looking at the integral from -2 to 1 of x cubed dx, first thing I have to do is I have to integrate x cubed. And the integral of any x to n is x to the n plus 1 divided by n plus 1. So if I'm looking at just x cubed, well, then n is 3, so I would have x to the 3 plus 1, which is x to the 4th, divided by 3 plus 1, which is 4. And I'm going to evaluate that from my lower limit, which is -2, to my upper limit, which is 1. Okay, so then if I plug them in, you take f of b, your upper limit, so 1 to the 4th divided by 4, minus f of your lower limit, so -2 to the 4th divided by 4. Okay, if I simplify that, 1 to the 4th is 1, right? If I take 1 to the 4th, it's just 1. So then I get 1 over 4. If I do the same thing then for -2 to the 4th, what's -2 to the 4th? 16, yep. So I get 16 over 4. And 1 minus 16 is -15 over 4. This one, I like that. So we're going to evaluate the area under the curve from 0 to 1 of x squared dx. Okay, so the integral of any x to any exponent is x to the n plus 1 divided by n plus 1. So in this case, n is 2. So if I integrate this, I get x to the 2 plus 1, which is 3, divided by 2 plus 1, which is 3. And I'm going to evaluate that from 1 to 0. So if I plug in 1 to my equation, then I get 1 cubed divided by 3, minus, if I plug in 0, I get 0 cubed divided by 3. So what is 1 cubed? 1. So I get 1 over 3, and 0 cubed is 0, so I get 0 over 3. And what's 1/3 minus 0 thirds? 1/3. So the area under my curve for x squared from 0 to 1 is 1/3. Okay, so most of the assignment you're just going to continue evaluating definite integrals like we did last week. You are going to work on page 318, 7 through 10, and 19 through 34.